How is everyone today? These ones at the front, I think, are all done. Okay, so a couple announcements. First is that some of the test cases were updated. So when I grade y'all's programs, part of that procedure is that I look at what you've written, and then sometimes I can see by the code that you've written that it has an error in it, but the test case is not comprehensive enough to detect the presence of that error. So then I have to write a more comprehensive test case. So several of the test cases have been updated, and some of you might have received a message that says it's not passing, whereas it was passing before. So that's the first thing. An example of that is that one of the exercises we had to do was do those 3 different implementations of GCD. And several of you, when you were writing your implementation of GCD, the names of the functions were GCD0, that was the one that used only subtraction, GCD1, the one that used modulo, and GCD2, the one that used the odd-even, the parity algorithm for GCD. And they're all recursive, right? But the thing, several of you, when you detected a case that you needed to recurse, for example, in GCD1, several of you recursed to GCD0. I assume that that's just like a copy-paste error, like you copied and pasted your code from GCD0, and then because GCD0 was correct, and when you copied and pasted it, you forgot to change the 0 to a 1, it's fine. But now those kinds of errors are detected. More concerning was that some of you, one kind of error was when you were implementing GCD1, you called GCD0. Well, you can't do that. But more concerning than that is that some of you, I suspect inadvertently, because I don't want to assume malice, when you were implementing some of the GCDs, you actually called MATLAB's built-in GCD, which of course generates the correct answer. Surprise, surprise. But now that condition is detected, and such a program won't pass anymore. So that raises the question, like, oh wow, how does that concern the due date? And, what about the due dates? So we're just going to define the due date for all of the programming assignments to be the end of the semester. So you can make as many updates as necessary, and we'll say that the cutoff is May 4th, yeah, at midnight. That way, we can say something nice like, May the 4th be with you. Something like that. Okay, good. Any questions about any of that?
So you did it recently, right?
Yes.
So all of our things are good and work on it?
You're right, yeah. Mm-hmm. Other questions? Okay, so first thing, today's the 29th. So some of you have prior programming experience. Great. If you do have prior programming experience, then it is a virtual certainty that you're aware of something called a loop, and you probably also are perfectly well aware that MATLAB has loops. And I'll remark here and now that they've been notably absent all semester. I've been purposefully not talking about them. It's not like I wasn't aware, but here's the thing. This is a math class, and the central objects of study in math is that you have a set, and you have the notion of what a set is, and that kind of thing. The central objects of study are functions, which take inputs from this set and produce outputs in that set. And everything that is computable, GCDs, everything that's computable, can be computed with functions alone. So strictly speaking, where programming is concerned, it simply is not necessary whatsoever to have a loop mechanism. It's just not necessary. And programming languages exist where there are not any loops. And these are among my favorites. But the fact of the matter is that loops are actually used a great deal. So now we're going to talk about them. And after we have a brief discussion about them, then there's going to be, for every one of the assignments where you had to write a recursive function, you're now going to have to write another one that uses loops. Lovely. So let's talk about it. So this first remark is called a while loop. So just as a reminder, in MATLAB has a keyword called if. So MATLAB has a keyword called if. And the way it works is something like this. You could write if x equivalent 2370. So if that evaluates to true, then this block in here will execute. So you could say if x is 2370, then y, we could assign y to be, I don't know, doesn't even matter, x squared, right? Okay, fine. Else, we could say y is the string, something like x was not my favorite number. End. So generally, what this means is that you write if and then a condition which evaluates to either true or false. In the case that the condition evaluates to true, you execute this block. Otherwise, this block is not executed. Okay, while, the keyword while is also similar. So a similar one is while, so MATLAB while. So you could do something like the following. You could say while x is less than 2370. So while that, you could say, okay, now I'll do something like x is equal to x plus 20. So what will be the effect of this line, by the way? Yeah, it keeps adding 20 is over and over again. And then I'll say end. So if this code were to execute exactly as it's written, if you were to just type this into MATLAB right now and say, do it, what would MATLAB do?
It would just keep adding 20 until it hits 2370, right?
So I'm asking a little bit of a trick question. If you were to type this and this alone,
Oh, well, it would
Just 120. Just 120.
nope,
nothing.
it would make an error. What error?
No function.
Didn't define it.
Yeah, it'll say, what's x? Right? If you type just this alone. So if you were to type just this at this point, MATLAB, when you ask MATLAB to evaluate the expression x less than 2370, it'll say, well, I don't know what x is. Okay, so let's give an initial value for x before the while and say something like, okay, let's write x is equal to 8. So now MATLAB will execute this without error. So what's going to happen is the following kind of thing. MATLAB will come to the statement x is 8, x equal 8, assign the value, and MATLAB will say, got it, fine, x is 8. Then it'll come to the while statement and evaluate the predicate x less than 2370. The present time, it looks up the value of x and says, oh, x is 8. And is it the case that x is that 8 is less than 2370? Yes, it is the case. As a result, you will jump in. You will enter this block, and it will be executed. So, what I'm telling you is that initially, the initial value of x, we make it equal to 8 before the loop occurs. Then the loop checks, well, is x less than 2370? It does a lookup. It says, well, x is 8. Is it the case that 8 is less than 2370? Yes, it is the case. It enters, and then it executes this statement. So first it evaluates the right-hand side. You've told MATLAB, I want you to evaluate x plus 20. MATLAB does a lookup for the current value of x. It says, oh, it's 8. So it does 8 plus 20, which is 28. And then, MATLAB says, oh, and you want me to store that in the name 8, in the name x. Okay. So then now the current value of x is what? 28. So that it comes down to here, to the end, and then it jumps back to the top, which is why it's called a loop, because conceptually you can kind of think that this goes back up here like this. Okay, so then now it hits the while and looks at the predicate and says, okay, you want me to check if the current value of x is less than 2370? Well, the current value of x is 28. 28 less than 2370 is true. As a result, you enter the while block and evaluate that statement. After that statement is evaluated, what will be the current value of x? 48. Okay, and then over and over again, right? I think that you understand the principle now. So then it will be 68, and then 88, etc. Dot, 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 dot. It'll come to pass that the x value is 2368. Right, so it'll come to pass that this is true because 2360 is divisible by 20, right? And then we have the 8 there. So it'll come to pass that this is true. Will you enter the loop? Yeah, because 2368 is in fact less than 2370. So then that the body of the while loop will be executed, and then the value of x will be updated to 2388. Then you go back to the top and evaluate the predicate one more time and ask, is it the case that the current value of x is less than 2370? MATLAB does a lookup. It says, oh, the current value of x is 2388. Is it the case that 2388 is less than 2370? No, it is not the case. So you exit. Any question about the way a while loop works? All right. So, good. There's another style of loop referred to as a for loop. In this case, for a while loop, there's a predicate at the top, or a clause if you like. The clause on the previous example was x less than 2370. For a for loop, there is not a clause. Rather, what there is there's a description of how a variable is going to be updated while the loop is executing. So here's an example. So in MATLAB, there's a keyword called for lowercase r. And here's an example. So you could write for I equal, how about, I don't know, 1 to 5. Then inside of the body of the loop, I'll write what? What would be something nice to write? How about m is equal to m multiplied by I.
What was the line up? What does that say?
Just a second. So what was the question?
Is it saying I is equal to
1 and then colon 5. Is that how you spell colon? That's weird. I don't write that word very often. Okay. If we were to copy and paste this into MATLAB and say, MATLAB, I want you to do this, what would MATLAB do in response?
It doesn't know what I or M is.
Okay, so then this line describes what I is. So that's a complete description of what I is going to be. But what? It doesn't know M, right? So it'll get past. We haven't described what this line will do yet, but I'm telling you right now that you will get in here, and because you're using M on the right-hand side of an assignment, M has to have a value. So when MATLAB gets here, it's going to say, okay, you want me to look up the current value of M and I and then multiply them together. And MATLAB will say, well, I don't know what M is. You're going to have to tell me. Okay. So for this example, I'm going to say M is 1. So now MATLAB will not have the, not complain about not knowing what I is. So, okay, in this little short piece of code, there's two variables, M and I. So now we're going to describe what MATLAB will do in response to this. So there's two variables, M and I. So as a result of computing the first line, when you evaluate the first line, M gets the value 1. But after this line is executed, and before the next line is executed, I doesn't have a value yet, doesn't have one. Okay, so then now we come to the next line, 4. M still has the value 1. And the meaning of 1 to 5, like that, 1:5, is you're telling MATLAB, I want you to execute the contents, the body of this for block. I want you to execute it once with the value I is 1. Then after you've done that, I want you to execute it with the value I is 2. Then I want you to execute it with the value I is 3, all the way up to and including I is 5. Okay, so what MATLAB does is it executes this line right here and says, oh, okay, fine. The first value of I is going to be 1. So that's the for line. After the for line is executed, it comes to the body of the for loop and says, oh, okay, I need to look up the current value of m and the current value of I, multiply them together, and save the result in m. So the current values of m and I are 1 and 1. The product of 1 and 1 is 1. So then the value of m is updated to be 1. And that doesn't change the value of I. So this was the body was executed. Now, once you execute the body line, then you come to the end and you go back to the top. And MATLAB asks itself, what's the next value of I? Well, what is the next value of I? 2. So the value of m is unchanged, but now the value of I is 2. So that's a result of going back to the top of the for. Then you enter into the body of the for, and MATLAB says, oh, you want me to look up the current value of m and I and multiply them together? Well, the current values are 1 and 2, and the product of those is 2. So MATLAB computes that and saves that in the value of m. But the value of I is not changed as a result of that. Okay, so then now it jumps back to the top and asks, is there a next value of I? So is there a next value? Yes. The next value of I is 3, but m is not changed as a result of that. Then the body is executed, updating the value of m to 6. Then you jump back to the top of 4. New value of I is the integer 4, but m is not updated as a result. Then you get into the body of the for loop, compute the product of the current values of m and I, you get 24. I is still 4. So that's, wait a second, for this should be body. This is 4. This is body. Fine. So then we go back to the top of the loop, and MATLAB asks itself, was there a next value of I? And the answer is yeah. The next value of I is 5. You get into the body, compute the product of the current values of m and I, which is 120. 5. So now we executed the body statement. Then MATLAB asks itself, was there a next value of I? And the answer is no. There wasn't a next value. So that's the complete all of the events that occurred for that for loop. Okay. Any question about this one? By the way, I hope that some of you can look at this and say, oh, I recognize that. I know what that is. What is that? That's factorial, right? In particular, because we said 1 to 5, this is computing 5 factorial, right? It's computing 5, right? Good. So these are the two styles of loop available in MATLAB. One of them is called, the first one called while, and the second one called for. So that hopefully raises the question of, well, we already said that evidently everything that can be computed without loops whatsoever. They can be computed with functions. So that raises the question of, why do you have while loops? Why do you have loops at all, right? Why? then the fact that there's two different styles of loop, I hope even raises the question even further and stronger. Like, well, if everything can be done with functions, then we don't need loops, yet we have them. And not only do we have them, but we have two different kinds of loops. Two different kinds. Okay. Well, in the end, the reason for their existence is one of them is convenience. Sometimes it's just convenient to use a loop, either because it's easier to write the program that way, or you're just accustomed to thinking that way. So it basically comes down to convenience. The other reason is that historically speaking, before people figured out how to think about computation, right? Because there was a time before there were computers, right? In fact, we're only like a century into it, which is nothing on the scale of history. To do iterated computation, the only game in town was something that was more or less exactly like a loop. Okay. So, remark. A while loop is used when, and this is loosely speaking, when you do not know in advance how many times the body needs to execute.
Did you say you do not know?
You do not. When you, and I said it, but then I didn't write it. When you do not know. How many times the body needs to be executed. Okay, whereas a for loop is used when you do, is used otherwise, more or less. Okay. So, well, an example of a case when you want to use a for loop is, for example, when you want to compute factorial of 5. Well, you know you need to do exactly 5 things, right? It's not a mystery. So if I wanted you to write a function that did factorial of n with a loop, well, then you should use a for loop, because you know exactly what needs to occur. So here's an example. Function m equal factorial, and then I'll say underscore capital L for loop. I need an input in, so then I could say for I equal, so what should be the beginning and the end? 1 to n. For I equal 1 to n, m is m multiply I. End. So if we were to execute this function as it's currently written, what would MATLAB say?
What's n?
What's M? Right? What's M? The reason why is because if we were to evaluate factorial underscore L, say at 5, then MATLAB's going to do, okay, for I is 1 to 5, and then it gets to this line and says, oh, you want me to look up the current value of M and the current value of I. Well, the current value of I is 1, but M is undefined, so MATLAB blows up. Okay? So what is the correct initial value for M? 1. It's a good thing I left myself some vertical space. Good. So, do you remember when you were computing the pyramid function? And you did it in 3 styles. One of them with a polynomial. That one, in a sense, is, from a programming point of view, the least interesting. And you did 2 different recursive styles. One of them was a recursive function that took 1 argument. And the other was a recursive function that took 2 arguments. That was the one we called TR0. And to do the pyramid function, you had to, the way we did it is we did pyramid TR, in turn calls pyramid TR0. And when it calls TR0, it has to give an initial value to the parameter that we called K. Do you remember that? What was the initial value? It was 0. It was 0 because why? Because we were adding, and 0. How was 0 special with regard to addition? It's the additive identity. So this is analogous to that. This is analogous to that. You're saying that, well, I'm doing a procedure, and I need to initialize the value that I'm working on. And because factorial amounts to repeated product, the initial value in this case needs to be the identity for product, which is 1. Good. Any question about this? Okay. So 4 is used when you know in advance how many iterations you need to do. What's an example problem that we've done this semester where you don't know in advance how many iterations you need to do? GCD, that's a good one, right? Because there's no telling what the GCD could be. So the stopping condition for GCD is what? Do you remember? How do you detect when you've found the answer? Yeah, remember that we in the definition of GCD, there's 2 arguments, the first and the second, and we arrange matters so that the first argument is always less or equal to the second, so that they're in order, numerical order. The stopping condition is when the first argument is 0. That's the stopping condition. And there's no telling when that's going to happen in advance, right? You can't tell when that's going to occur. You just know that you're supposed to stop when it does. Okay. Good. So let's see if we can write that down. So, for example, function. I'm going to need to do it on the next page because it's going to be biggish. So, for example, function d equal GCD L of A and B. All right. Well, remember the word greatest in the name greatest common divisor is a little bit slippery, because greatest has to do with an order, but it's not the order that, when you think of numbers, it's not the order that everyone wants to think about. It's not the linear order. What is the order? When in a math class, when you say greatest, that means that you're talking about an order, at least a partial order. This thing is greater than that thing. But when you're talking about numbers, at least when you're taking a 2000 level course, when you say greatest, most of the time you're thinking of where they are on the number line, left to right. But when you say greatest in the context of greatest common divisor, what order are we talking about? We're not the division order, right? We're not talking about distance from the origin. We're not talking about which one is further to the left on the number line. That's not what we're talking about. Okay. As a result, in the linear order, on the number line that is there a greatest natural? There is not. In the linear order, there is no greatest. But in the division order, is there a greatest? Yeah. What's the greatest in the division order? Zero. Which is interesting, because in the linear order, is there a least natural? Yeah, it's zero. So in that kind of, that's like a microcosm of just how different they are. In the linear order, the least natural is zero. In the division order, the greatest natural is zero. In the division order, what's the least natural? The least natural. It's 1, right? Because 1 divides everything. Therefore, 1 is division less than everything. Okay, good. As a result, that means that there's a particular special case we need to take care of. Not that. We need to take care of when they're both 0. Because if they're both 0, then the greatest common divisor is the greatest divisor of all, right? 0. So we need to handle that first. So if the first one, and I'm assuming that I'm not doing any error checking. I'll leave that to y'all. If the first one is 0, and how do I say and the other one is 0? 2 ampersands, right? So ampersand, B is 0. Then the answer is what? D is 0. If they're both the greatest natural, then the answer is the greatest natural. Otherwise, we're good to go. So else. So now we need to put them in the right order, because it might be the case that I called your function and the first one is 70 and the other one's 23, so that they're not in the right order. So let's put them in the right order. How do we do it? Sorry?
You just switch the orders and make A, B, and B A.
Okay, but I want to do it without a recursion. So in the first place, we need to check if there's something that needs to be fixed, right? So else, I could say else, now I need to check. If, what's the condition I need to check for them to be reordered? If A greater than B. Because the alternatives is that A is less than B or A is equal to B, and both of those are permissible. So if A is greater than B, we want to switch them around, but without a recursion, right? The way we did it before is we just recursed and put the arguments in the opposite order. but now we want to do it without a recursion. So, well, here's a problem, is that if I try so I'm going to write something, but I'm going to have to erase it. So if you're writing in pen, be careful. So could I do this? I could say, well, A equal B, and B equal A. Would that work?
No.
Nah, right? Because by the time you do that, they'll both be equal to whatever the original value of B was. How do we do it? So just leaving myself a comment, this won't work. Blah. So I think you might be saying, let's do it like this: A, B equal B, A. I think that's an excellent idea, and in fact, in a lot of programming languages, you can do something that's more or less just like that. But in fact, in MATLAB, this is a syntax error.
So do you have to create a separate one?
Yeah. Yeah. So it's not this one either. Rather, yes, you say, okay, well, I'm gonna overwrite the value of A currently. So what I need to do is I need to save the current value of A somewhere else, so it's out of the way. So I'll say, okay, T is equal to A. So that copies the value of A to the location we're referring to as T. So now I can say A is equal to the current value of B. And now I want to update B, so what's B then? B is equal to T. Ah.
And they're all on separate lines.
Those are all on separate lines, yeah. Any question about that? So,
Can you put them on the same line and put ampersand between everything?
No.
Or does it not work?
The ampersand thingy only works when you're doing tests for equivalence.
Okay.
The double equal, right? Which is a test for equivalence, whereas this, a single equal, is an assignment.
Oh, I was talking about the double and sign.
I think I understood you correctly.
Okay.
So these are tests for equivalence, and ampersand is logical and that means that it has two arguments, a left argument and a right argument, and they need to be a logical value and a logical value, meaning true or false and another true or false. Okay, so by the time this if block executes, they're in the right order. A and B, I mean to say. So now, what's the stopping condition?
Oh, when A is equal to 0, it produces B.
Right. So now we have the loop. So while. And how do we know when there's more work to do? Okay, and in fact, I'll write it like this: while A greater than 0. So while A is greater than 0, we have work to do. Okay. So I'm going to do the simplest possible kind of GCD, the kind where you do subtraction only. Right? So how do you do it? But we're not going to recurse. No recursion. Previously, while was against the law. Now, recursing is against the law. So, what you do is that if you're doing GCD using subtraction only, we've arranged matters so that A is less than B, so B is the big one. The way you do it is you say, okay, now I'll compute two new values, and the way I'll do it is I'll subtract the small one from the big one. Okay, so then I'll compute, say, T is the big one minus the small one. So I know that t, because of the conditions above, I know that t is greater than or equal to 0. It couldn't be negative. But it's conceivable that you know, we don't know which one this is going to end up being. Is this going to end up being less than a or greater than or equal to a? So now the question is which one needs to be a?
Oh, so you're saying
So what I'm saying is that
if t is less than a, then t needs to be less.
yeah, so here I'm writing a little comment. See my little percent sign? Now, it's either the case that we need, well, I'll say it like this. A and T are the new A and B. So we were just working with A and B, and we've computed a T. And we're not what we need is among A and T, we need the new A to be the lesser, and we need the new B to be the greater. You see what I mean? So the question is what's going to be the new A, and what's going to be the new B? Well, it might not be T. It might not be T because they might have been reversed. It's conceivable. So how do we check? So we need to do an if. If what?
If t is greater than a,
Okay. If T is greater than A, then what's the new value of A?
t, or no, a, is still
It's still A, right? Doesn't need to change. What's the new value of B?
t.
T, right? The new big one is T. So we need to write B assigned to value of T.
You don't have to write being assigned twice for a, correct?
Right. You don't need to. And in fact, if you were to write A equal A, MATLAB would complain and say, "Yeah, I'll do it, but I'm gonna complain. I'm gonna issue a warning." And then my grading program will say, "Hey, you're not supposed to have any warnings." So else. So conceptually, this condition was asking, is the big one going to be T? And if yes, then we do that. Otherwise, that means that the big one's not going to be T. What's going to be the big one? Yeah, the big one's going to be A, so we need to say that B is A. So the new value of B is A. And the new value of A is T. So end. End. Look at all of them. Any question about this? It's lovely, isn't it? No recursion. Well, it won't matter if they're equal. So that is to say that it just won't matter.
And that should produce the greatest common divisor.
Yeah, I mean, unless I've made some kind of error that I can't imagine, which is, you know, that's conceivable. But I'm fairly sure that this is right. Good. So in summary, don't worry, I'll scan that and post it. In summary, there's two kinds of loops available in MATLAB. One of them is called a while loop, the other called a for loop. What is the distinction between them? That is to say, under what circumstance do you use something like a while loop?
When you don't know how many times you're going to do it.
Right, when you don't know how many times. And under what circumstance do you use a for loop? When you do know, right? Else, right? So that being said, This is a remark. Sometimes when you have a loop, it comes to pass that it might look like this. That the structure of the loop is like while x more than 2370. Then in this location you do some work. You do some work in there. Then it comes to pass that you check something right here, like well, if I don't know, whatever, it doesn't matter. If y, some other variable y defined elsewhere, is equivalent to 2370 squared. So if that's the case, we'll do something. I'll write something in that body, and then end right here, and then in this location you do some more work. Suppose it's the case that that this test right here, if that's true, then you don't want to do this part. You want to jump back to the top of the loop. So you don't want to do this part if that's true. You only want to do this part if it's false. So if in the body of a loop you've detected, oh, I want to jump back to the top. I don't want to do anything below this point. The command to jump back to the top is called continue. That means jump back to the top. So, this test might be something like, if y is even, then I'm going to do that. I'm going to do that stuff. But if y is not even, I don't want to do. I'm not going to do that stuff. Furthermore, so that was a remark about the continue keyword. Sometimes it's the case with either a for or a while loop, either one, but I'll write a while loop. You have something like while x is more than 2370. You do some stuff. And maybe there's stuff even after it. You could ask something like, if x is equal to 2018. If that comes to pass, that means that I don't want to do any more work. And furthermore, I don't even want to jump back to the top. Rather, I want to stop being in this loop altogether. I'm tired of it. I want to be done with this loop. The key word that says I'm done with this loop is break. Okay.
So when you break, you just go to the end of your while and then carry on after that? Is that
Correct.
Okay.
It's unconditional. It doesn't go back to the top. It's immediately. I'm inside of a loop. I am going to proceed to the line immediately after the loop.
Okay.
It is a syntax error to have a break outside of a loop.
Okay.
And it is a syntax error to have a break, a continue outside of a loop. Okay, well, break's kind of nice. Break is saying, I'm done with this loop. Let me out. Well, there's one last keyword that I'm going to write. As a reminder, we spent all this time, I spent all this time carefully avoiding loops altogether and only using functions. But the notion of being able to say, I'm done with this loop is nice enough that there's actually another analogous keyword which says, I'm done with this function. Let me leave. In that case, you could have something like this. So function y equal f of x. You can have, whatever's in there, and it, you might come to pass that you're going to check if we compute the modulus of z by 2370. And determine that is 0. Presumably z was computed in the whatever location. If that's the case, you might say, well, if that's the case, then y needs to be 2370. And maybe there's a lot of other expensive work down here. And there's no need to consider any of it. There's no need to do the expensive work if, in this location in the function, you've already established the answer is 2370. I just want to leave now. The I'm ready to leave the function right now keyword is return. And for those of you that have prior programming experience, you need to be a little bit careful because the return keyword in MATLAB is not the same return keyword in other languages. In other languages, you say return and then you give an expression, like you could say return 8, which is to say that the output of this function should be 8 and I want to leave right now. Rather, in MATLAB, the way it goes is you have to assign an output, a value to the output, right? The name of the output is y. So you have to say, okay, I've assigned a value to the output, and now return. Let me out. Any question about these new syntax items in MATLAB?
Will it continue jumps to the top of the current?
Of whatever loop you're in. So in particular, there's in principle nothing wrong with having loops within loops, within loops. Right? So then continue jumps to the top of the immediately enclosing loop. It's a different matter like if you have loops within loops within loops. And you might imagine, well, what if I want to jump to the top of that one? Well, that's a different problem altogether. Okay. So now, if we were to try to solve, I want to remind you of the problem of quotient and remainder. The way that we computed quotient and remainder is we took a dividend, which is the fancy name for the number of M&Ms, and a divisor, which is the fancy name for how big a handful you're going to take. And the way we did it is we took one handful at a time. 2,370,000 M&Ms. That's a lot of M&Ms, right? And if we wanted to break them into groups of size 7, well, in principle, you could answer the question by taking 7 at a time, right? You could. You could do it. It would take millions of steps to do it. Whereas, you know, in grade school, you learned how to do something like this. So how about divide 2370 by 7. Now, if you wanted to do this, if I gave you 2,370 M&Ms and I said make groups of size 7, you could come to the answer by taking 7 out and keeping a little tally of how many times you took out 7. But gosh, if you were to do that, it would take like at least like 300 steps. So I'd like to remind you of the way this works in grade school. In grade school, when you're given this request, the way it works is that the teacher says, 2370 is in the house, and 7 is outside, and it wants to come in. How many times can 7 go into, well, you take one digit at a time. How many times can 7 go into 2? It cannot. So you take another digit, 23. How many times can 7 go into 23? 3 times. But that 3 isn't really a 3. It's actually a 300, right? That's what it actually is. Then you take this 3 and you multiply it by 7 to get, you know, the 3 realizes it's in a division problem. It jumps off the house in desperation, hits the 7 on the way down, okay, multiplies to become 21. You write the 21 right here, and then you subtract, and you get a 2. Then you carry down a 7. So then, how many times can 7 go into 27? 3 times, right? We're almost done. This 3 jumps off the house, hits the 7 on the way down. You subtract that much, and you get 6. You carry down the 0. Good. So then now, 7 wants to come in. How many times can 7 go into 60? 8 times. You write the 8 right there. It jumps off the house, blah, blah, 56. Subtract 4. So the answer is that the quotient is 338, and the remainder is 4. And I'd like to point out that we did that in, well, about like 4 or 5 steps. That's better than 338 steps. So one of the coming assignments is going to be, we're going to do the grade school algorithm, and it's only going to take this many steps. It's not going to take 338 steps.
We're going to do that with a loop, or?
We're going to do it with recursion and with a loop, which means, well, we'll just see. Okay, so have a nice Thursday.